at KiwiBot, and he's going to be talking about his robot and working on the last mile problem.
Thank you so much, Austin. Thank you, everyone, for being here. Can you hear me well?
Yep.
Awesome. So my name is Sasha Yatsenia. I'm head of product at Kiwi Campus, and we're here to make the world a better place with robots. So we build little food delivery robots that roam the sidewalks and deliver food to your doorsteps. I'd like to just say a few words about my background and how I got here. I have a fairly unconventional profile for people who build robots. My parents actually fled the Soviet Union, and we settled in the US early 1990s. And since then, I was growing up in a really multicultural environment where a lot of ideas, a lot of different worldviews were challenging me and kind of pushing me outside my comfort zone. And this has always made me feel somewhat welcome everywhere, which is a really great feeling, because that way you're able to perceive ideas, to absorb things like a sponge, and to learn really quickly. So after the 1990s, we moved to Switzerland, where I grew up. I went in school there. I built a couple of companies over there. I built my first website when I was 11, my first business when I was 14. My first startup that actually started scaling around 19. And after that, I started working for corporate. Wasn't the best idea. But after that, I decided to just take a one-way ticket to San Francisco, and I ended up here building robots. So that's kind of a short summary. And now a little bit more about Kiwi. So Kiwi was actually started in 2017, really early 2017, and we did the very first delivery with robots around the 2nd of March 2017. Since then, we've done over 20,000 deliveries. We've built over 100 robots, and we're covering 100,000 consumers in Berkeley with a commercial robotic delivery service. That means anybody in Berkeley right now can get a KiwiBot and get food delivered by a robot from 10 to 10, 10 a.m. to 10 p.m. And that's probably the first time in the world that anybody has actually had access to deliveries made by a robot, like a commercial service. It's a really interesting journey that started off in an attic. We were in an attic on Channing Street in Berkeley. I don't know if anybody has been there, but it was like a really interesting mentality. It was just a bunch of geeks just playing around with electronics. We didn't really have anything that worked. We had to build a little robot that was essentially a shopping basket on an RC car. And it was really basic. We had an Arduino inside connected to a Raspberry Pi. And we were able to drive it outside on the sidewalks in Berkeley by having a little phone strapped to the top of it. So we just had like a phone sitting here and like a little phone holder that's usually made for cars. And we were just sitting there, driving around, letting people know that, okay, robots are coming. You know, we're actually going to deliver food with robots. That was a really, really basic version. We managed to do 1,000 deliveries with it. We managed to validate the concept. It barely worked. Like, it was a lot of motivation, a lot of effort to get that far. But it allowed us to realize that design is very important when it comes to robots, particularly the design of the interaction between people and robots. And that's why we captured all those learnings and went on to build our second generation. In our second generation, we still had mostly off-the-shelf components. We had the same Raspberry Pi. We ditched the Arduino in favor of a Pig's Hawk. And we started playing around more with the design, how it would interact with people. So we started building a shape. We built a shape that's really friendly. It's made to be resembling kawaii culture. It's this Asian culture that makes like everything super cute and friendly. And we decided to capture that and embrace that, to provide people a robot that wouldn't scare them, that would mesh seamlessly within the fabric of our sidewalks. And it was hugely successful. We built 25 of those robots, did thousands of deliveries, grew like crazy, and it was a great learning experience. But there were problems. Since all of these robots were built in our office, at that time we were in Skydeck with Kyle and Brad, and we were all building them out of just like a regular office without really access to manufacturing, like to big resources, to production facilities, and it was hard to get a repeatable product. Like, it worked for demos, mostly, but then when we were going out and doing deliveries, we had a ton of problems. And we also started discovering the reality of life, and that if you leave a robot outside, people might try to like open the lid, try to take the food out. It's like we had to build features that prevented people from like taking out the food just because they would open the lid. So we started experimenting a lot with different designs for the lid mechanism. That was a really, really tough one to tackle. It's like a super simple mechanism, but we tried like 100 different things to get it just right. I don't think we have it perfect quite yet, but we're getting there. We tried a lot as well with the interaction design. So we actually put in a screen. You can see here We have a little tiny screen here, and it's basically literally a Raspberry Pi touchscreen. It's a HDMI Raspberry Pi touchscreen, super basic thing. It's used in a lot of electronics projects, but it allowed us to communicate emotions with the robot. And once people start to see that the robot feels something, even though it's just a video on a loop, they start to feel for it. You know, they start to think it's a member of their community. And I do a lot of like user testing. I talk to a lot of focus groups and study groups where I get to understand how people feel about our robots. And somebody once told me that they think people in Berkeley like robots more than like people. So I think we've got quite far with that. It also helps us a lot with allowing us to mesh seamlessly within sidewalks, within campuses. People don't really kick the robot. If the robot gets stuck in a pothole against a root or something, people rescue it within seconds or minutes. So it's really, really great to see that community like really teaming up and like going for the robots. And the reason for that is because we're really changing the way people get food. Because right now, if you want to get food delivered, you're paying between $5 and $13 for that privilege. And that's not exactly something everybody can afford. It's a luxury. We're bringing that cost down to zero. We're pretty close right now. We're offering a commercial service for $3.8, which is already lower than Uber Eats, DoorDash, Caviar, all these services. And we're targeting even more. We have programs, for example, Kiwi Prime, that get you food delivered for free. They have a fixed monthly fee, kind of similar to Netflix and stuff like that, and you get free food delivered. We have people who literally have used this. Last semester, we had one person who ordered more than 350 times. So we have a lot of people who order. It's really impressive. So yeah, second generation robot went great, lots of learnings. And then we said, okay, we need to scale this. We tried scaling this here in the Bay Area. Really hard to find manufacturing technology that was affordable and accessible. So my company just shipped me out to China. And they're like, here's China, figure it out. So I just arrived in China, no experience whatsoever. Nobody in our company had any experience dealing with manufacturers in China. And it was a great learning experience. I had a lot of preconceived notions going into China, expecting certain things. But in reality, it was actually super easy to build this. You have a couple of peculiarities, like you have to be very specific with what you want. You have to be very specific with your expectations, especially when dealing with money. As soon as you send somebody money, any promises they have left over, that doesn't get done. So like small learnings like that. But it was a really great experience because we went from building offices in our office to actually building a supply chain and a production line that can crank out these robots. We want to be at a stage where we can do control P. Like with these robots, we say, okay, we want 100 robots to open the city. We're not quite there yet, but we already did 2 manufacturing runs, 2 mass production runs of these robots. The first time was 50 robots, the second time was 100 robots, all of this 3rd generation right here. And it's been really great. The first time we had a lot of learning experiences. We spent 4 months in China, had about 7 people from our team and a whole bunch of people from our contract manufacturer out there helping us. We had 0 DFM, design for manufacturing, when we walked into China. We had no idea of how to manufacture this, but we learned along the way. We learned how to make really specific schematics and how to make people understand what we want to build. And getting some things manufactured, like for example, the carbon fiber chassis, the casing, that was incredibly hard. Our designer had to fly to China and literally sit with the factory owner of the factory that manufactured this to like get it exactly as he wanted. And that's not something you can communicate over schematics or anything. It had to be done like by hand, like slightly adjusting shapes and stuff. So it was really interesting to see the creative process. We had great adventures going into factories. We went into PCB factories, we went to battery factories. Battery factories are crazy, by the way. It's like almost entirely automated, and they have huge machines running super fast, and you can't take pictures or videos. So super exciting. Yeah, so after 4 months in China, we shipped 50 robots just before Chinese New Year, and they get stuck in China for Chinese New Year because we had a logo on the box, and they couldn't verify it. They couldn't verify that we own the trademark. So they got stuck in China for Chinese New Year. Then we received them in Berkeley. We received 50 robots. We spent probably like 3 or 4 months remanufacturing them, doing some tweaks. We had a bunch of problems, a bunch of things we thought would come in the box. I'll get into that a little bit later. But that didn't work out of the box, so we had to do a lot of fixes, a lot of things. We deployed these robots to a couple thousand deliveries, and then we realized that we need more robots. So we sent another team out of China. This time I wasn't leading it. And these guys, they took what we had, they took all the learnings, and they just made a robot that was a little bit more reliable, a little bit more manufacturable, with a small iteration just to improve the quality of the robot. And we actually started rolling around with this V3.2-ish around like a month ago. So it's been really great. Now we've built to date over 150 robots, and this guy is the star of our fleet. So to tell you a little bit more about how this works, this is a really incredible piece of engineering. We're using an NVIDIA Jetson TX2 to run this boy, and we're using a lot of cool architecture. So since we have a ton of robots, we have to find a way to deploy robots really easily. And you can't just like SSH into every robot and like push your Git changes or whatever like that. That's like not a scalable solution. So what we decided on using is Balena, and it used to be called Resin. Maybe some of you have heard of that. It's a really cool tool that allows you to do git push Balena master, and then code gets deployed to all of your robots, like almost immediately. It has to download the image and restart the robot. Super awesome, great tool. It allows us to manage our fleet of robots really well. So on top of Balena, we have Docker. So we have one main Docker image that's actually running our ROS operating system here. So we're running ROS on top of Octo Linux, I believe. Yeah. So ROS runs on top of Octo Linux, and we have a bunch of ROS nodes. We have ROS nodes that are capturing the cameras, for example. That's a really complicated ROS node because we have 6 cameras on board, 5 in the front and 1 in the back. And we have a couple of different ROS nodes that are using that data. And we weren't able to figure out how to share like a USB camera between different processes. So what one of our guys actually did was they built a tool that took frames from the frame buffer and put that into memory in such a way that you can access it from any NumPy instance the same way you would access a webcam. It's black magic that's beyond my understanding, but it works really well. So we actually had to do a whole bunch of hacks like that because some things don't exactly work out of the box, some things don't have documentation, some things don't like really function too well as you expect them to function. Another example of this was GPS. We went through like 4 or 5 iterations of the GPS. This is actually the GPS antenna right here. We used to have it inside, we used to have it like deep down over here, then we used to have it on top here. Now we have it outside here in a 3D printed case. And this is actually 3D printed. Like, you'll have to touch this later. The first time I saw it, I didn't believe it, but this is 3D printed. We actually found a factory in China that 3D prints things super fast, 24 hours turnaround, and it's like injection molding quality. It's insane. And it's all FDM printed with like filament printers. It's really cool stuff. So yeah, over here we have the GPS with a little flag that sticks out of it. Really cool stuff. We have other things on the outside of the robot. For example, here we have a 4G antenna. It's giving us a lot of headaches. So the principle of operation of this robot is really interesting, actually. It's always connected to the engine, it's always connected to the cloud, and we're always supervising these robots. So we have a remote operations team in Colombia who's actually sitting behind screens and monitoring these robots when they're outside. And at first, we just built a teleoperations suite, so we were able to control these robots over WebRTC really seamlessly. I actually built a WebRTC video transmission technology that was originally sitting on this robot, and we were able to control the robots with just hundreds of milliseconds latency. That allowed us to really prove the concept and validate that people want robots, that it's actually something we can do. And then we started building more autonomy on top of it. So now our robot is kind of as autonomous as a Tesla, sort of. So we have autopilot. We're able to go in straight bits pretty well. We're able to go like in sidewalks where we're seeing people, navigate around people, obstacles. That works pretty well. I'd say it works 8 out of 10 times, something like that. But for the most part, we're actually using a system that we developed that uses waypoints. So we navigate the robot using waypoints. So we have the remote operator in Colombia who sees the robot, who sees the map, who sees the video feed, and they're able to plot waypoints that guide the robot. So it's not a fully autonomous approach, but it's still using AI, artisanal intelligence, to drive the robot. So it's a great robot. We've done a lot of cool technology for it. There's still a lot of things that can be improved. 4G communication, said earlier, we have this antenna here. A major challenge, sometimes it just drops off from the network. We have to manually go to the robot and reboot it. We don't know why. We've talked to both several major carriers in the US. We've talked to many engineers. We've tried many different antennas, many different MiFis, many different routers, and it still happens. So we're still working on that. What other problems do we have? We have rain, that's a bit of a problem. We haven't figured out how to make the robot fully waterproof, so when they're outside, they're basically running around in onesies. We have like little plastic onesies for them. What else? Batteries. I don't know if you heard, we got unfortunately a little bit of bad press last year. One of our robots started smoldering and experienced minor flames. It was like in the middle of the Berkeley campus, so we got a lot of attention for that. Like BBC, Bloomberg, Wall Street Journal all talked about it. So yeah, good press is bad press, I guess. Exactly. And that made us take his batteries really seriously. So even tonight, when I was coming here, I asked like 4 batteries to my maintenance team, and they're like, "You sure you can't just do it 2 batteries? It'll be safer." So we're really, really careful with batteries now. We have like a really strict process. The reason actually we had that minor incident that was contained and isolated was because we did not follow the process. We had a process in place where whenever you change the battery, you have to check to make sure it's charged. But the person who was changing the battery did not check that. So they changed 3 of the batteries with charged batteries and 1 of the batteries with discharged batteries. And over the period of like 25 minutes, we had this equalization. I don't know what it was called. Rebalancing. We had rebalancing that we were actually afterwards able to see in the logs and the data. But unfortunately, at the time, we didn't know that was happening, and we only found out that we had a problem with the robot after we saw it on social media. So that was a great learning experience. The great thing is that people reacted super positively to it. Everybody was like feeling really sad and like had a lot of empathy to the robot, which is again like a really important part of like building a brand and identity, a friendly face that can mesh seamlessly with the community. What else can I talk about that's super exciting for you? So we have, inside of here, we have a Jetson TX2 that sits just like right here. We used to have a Pixhawk, but we had some problems because it's really stupid problems actually. Like we have a bunch of cables that are going into it, and sometimes they weren't plugged into the right place. So we just decided to make our own PCB. Now it's far simpler. It's open source, so we were just able to modify it as we wanted. What else do we have? We have a couple of small PCBs, but it's mostly like for distributing power, distributing cables. We're still using the dev board, but we're planning our next iteration to go away with the dev board, the NVIDIA Jetson TX2 dev board, and just to take the SoC, the actual Jetson TX SoC. Down here, the chassis, it's a red cap chassis. It's made for RC cars. It can go 70 kilometers an hour, but we limit it significantly to about like 3 kilometers an hour. What else? Yeah, it's just a super cool robot. And on the AI side, I'm really not familiar with the AI side, how this works really, but I can give you a brief summary. So we have several cameras in the front. We have 3 cameras over here that are probably the most important. And we're capturing frame by frame. We're looking at these frames. And based on all the data that we've captured in the past, we've captured about 4 million images on sidewalks in Berkeley, we're able to predict which steering angle we should take. So we're taking into consideration people, objects, bicycles, cars, bikes, all these sort of things. And we're creating 12 buckets. And we basically calculate the probability of which bucket would be the safest to go at. So these are buckets of steering angles. So once we have this bucket, we take the highest probability, then we create an exponential smoothing curve, and our robot takes that path. And for the most part, it's pretty good. It's not perfect. We still have some difficulties detecting things like bike racks, poles. If you have some sort of thin poles, we don't really detect that well. We have some really cool technology that we're still developing, but it's for crossing streets, for crossing sidewalks. The way we detect traffic lights is pretty interesting. We trained like a pretty big model with a lot of traffic lights. It was a really intensive process that we had a bunch of people just like selecting traffic lights from pictures. We also have a way of detecting the yellow pads, like the accessibility pads of different crossings, like zebra crossings. That allows us to drive the robot pretty safely across. But we're building additional things. We're building reliability also. If the robot is driving through the middle of the street and it loses internet connection, for example, it will continue driving. So yeah, we're building a lot of cool technology on top of it. If you have any ideas, any feedback, we'd be super interested. And I just want to show you one video of how this looks like in reality. So hopefully this will work.
Or just relaxing at home. You don't want to stop to think about food. That's why you use Kiwi. With Kiwi, you just open the app, pick a restaurant, pick some food, and hit go. Immediately, your order is sent to the cook. As soon as your food is ready, a member of our staff is dispatched to the restaurant. The courier can pick up orders from multiple restaurants in a single cycle. As the courier picks up the food, the KiwiBots head to the meetup point. Once a batch of orders have been picked up, the courier heads to the meetup point to transfer them into KiwiBot. For the last leg of the journey, the KiwiBots sprawl out through the city streets and sidewalks to your location.
You get a push notification when your order is arriving. Only you can open the KiwiBot using the app.
Day or night, Kiwi delivery is only a click away.
Thank you so much. Does anyone have questions? Yes.
Two questions. Did you have to do anything with the city to get permission to drive on the sidewalks? And then B, the typical question I keep asking people that do these is, tell me about the crazy people and how they interact with us.
I love those questions. So, typical Silicon Valley startup fashion, we didn't ask for permission, we asked for forgiveness when I first started operating these guys. So we literally just deployed them on the streets of Berkeley, started delivering, and eventually negotiated, and now we have permits to go to 12 cities. So we're actually like really good on that front. We are careful about doing that method now, just going into place without permission, because we had some bad experiences with that, and it creates bad vibes in the community, so we don't want to do that too often. In terms of your second question, crazy people, yeah, bunch of crazy people. With our second generation, we had a big problem. We couldn't close the door properly. Now we have a pretty good locking mechanism. It's not perfect, but it prevents like 99% theft. On our second generation, we actually have a lot of problems with people just like opening the robot and taking other people's food. But problems with other types of people. One time we brought the robot to San Francisco, like near Market Street, and a person started getting undressed and used the KiwiBot as a wardrobe. So I guess things happen. I don't know if we can do anything about it, but I have to say that whenever somebody does something with the KiwiBot, if it's like nefarious in any way, people around them will judge them instantly and will critic them and like will make them stop almost immediately. So for the most part, we don't have any problems with crazy people.
What about people stealing the whole?
We've never had that happen actually. We have redundant GPS inside. So like even if you manage to disconnect some batteries or some things inside, it will still know where it is. And we haven't lost like a single robot to 2000. Yes.
Have you thought about like having something where if somebody's molesting the robot, it like poops out a candy or something, so they'll like take that and leave it be?
That's a great idea. Right now we're actually working on putting in an upgraded alarm system, so like we'll make like a small tone that'll alert other people in the community that something's happening. We're also experimenting with like using the face to like project like sad emotions or something like that. So those are some ideas we're working on. Yes.
I have two questions. One is, how does it handle, what's the interaction process like for narrow sidewalks, especially if there's a wheelchair? And as someone who has heard that San Francisco is currently against a lot of the electric scooters that are riding on the sidewalks, how does the robot handle sidewalk, especially with wheelchair interactions? And are the faces programmatic, or are they procedurally generated through different interaction purposes? Or do you have like a script that just runs like different interactions for different environments?
Yeah, so two fantastic questions. So the first one, wheelchairs, for us, it's still a challenge. Typically, if we see a wheelchair, we just manually like move the robot backwards. We have a camera in the back, so we just move it out of the way.